Of time, it is appropriate, or in order to be clear about the scope and the context with which the term environment will be used. This will facilitate in outlining or understanding the scope of the virtual laboratory sessions. The term environment in general is used very commonly and conveys different meaning in different contexts, but has much broader sense. Are known to us and are included in or find place in the periodic table. In general, anything that is made up from only one element, one kind of element, or from one kind of molecule is referred to as a pure substance. For example, pure gold, what we refer to as 24 karat gold, that is made up of only gold as an element. Ornaments for that matter are made of gold, but they are never pure gold, because in order to make the ornament, some other metal is mixed with it. So let's not get confused between pure and impure. So if an element, if a matter or a substance consists of more than one element, then it is referred to as impure. But if it consists of only one particular element, then it is referred to as pure gold. On the same line, if a particular substance, for example, when we talk about pure water is made up of only water molecules. It is important also to notice it is not the impure thing that is of concern to us. Okay? But what is important to understand is pure means consisting of either only one kind of element or only one kind of molecule. And pure water, when we mean, it is only and only H2O molecules. It is also important to note, in nature we rarely get pure water. In fact, it is very, very difficult to get pure water. And so when we are using water, it is not always that we like or we want to use pure water. Impure water is fine, but impure water should not be confused with polluted water, and we'll look at it in future. What is the difference between impure water and polluted water? It is important to recognize, however, that the word environment does not refer only to aggregate of surrounding things or just the physical aspects. It also includes aggregate of surrounding conditions or influences. Surrounding conditions or influences do not occupy any space, any physical space, or cannot be referred as matter and do not have any weight. I cannot put those kind of conditions or influences on a weighing balance and weigh it. It just doesn't exist because it does not have any physical space as well. It does not occupy any physical space as well. So, for example, when something is seen, that's a condition. When you see something or spot something, say for example, suddenly a big snake, say cobra, is spotted inside a room. It does not affect the air that we breathe, but it does create a condition or influence, says people in the room. Or for that matter, something is being watched or heard or read. Say a news item is broadcast on TV. Again, air quality does not get affected, but people do get either in a state of shock, depending upon what you watch or listen or read, or sometimes get excited. For example, if you see a news item which is more about violence, more about somebody's death or some terrorist attack, obviously we get into a state of shock. Or in other case, let's say you are watching a game and your favorite team is winning. You do get excited about it. Okay? So when you are watching a game and your favorite team is winning, that's a kind of condition. And so surrounding conditions or influences are also referred to as aspects of environment, because it does affect someone or the other. Further, at this point of time, it must be noticed that when physical aspects, or for that matter conditions or influences are considered, they always are with respect to some effect. And so additional qualifying words are needed to fully understand the meaning of the word environment. And that is especially as affecting or that affects. Now the question is, affecting or that affects what? To answer this further qualifying phrase, the existence, survival or development, growth is needed to answer the question. Okay? That is existence, survival, development, growth. Okay? An additional qualifying phrase for qualifying physical aspects, that is things, conditions or influences, okay, with respect to what? Then the next question is, when you are talking about existence, survival, development or growth, then the question comes in, whose existence, whose survival, whose development or whose growth are we talking about? Okay? The answer is in the next line, that is of someone or something. Okay? And when someone is referred, someone is considered, it refers to living, or in ecological sense of the word, it means biotic. And when something is considered, it refers to non-living, or again in ecological sense of the word, it means abiotic. Now, for study purposes or as subject matter, environment is typically divided or classified in two distinct divisions or classes. This one class, this is another class. One that refers to physical or material, or we can say hardware part of it, and is included as part of physical sciences and engineering studies. Physical aspects of the environment are further divided in three parts. One, depending upon the three phases or three states of the matter that are known to us: gaseous, liquid and solid. One that refers to gaseous phase of the matter, that is atmosphere or air. The other refers to the liquid phase of the matter, and that is hydrosphere or water. And the third that refers to the solid phase of the matter, that is terrestrial. In that we include rocks, soils, etc. The other class or the other division refers to non-physical or non-material, or we can say software part, which you can't really have a feel of it. Okay? You can't, it doesn't occupy space, neither it can be weighed or filled into any container. Okay. And is included as, so non-physical part, okay, or the non-material part or the software part is included as part of studies generally as humanities and social science, or economic science, or computer science. For example, when you are writing a program, okay, the program is a software environment, okay, like for example when you are working on an operating system, the operating system is a software, okay, which is an environment for something, okay, and the software on which it runs on the chip, that is your hardware part of it. So hardware is something that can occupy space, you can see that, weigh it, and so on and so forth. So the non-physical or the non-material aspects of the environment are also, as a subject matter, are divided into social sciences, cultural aspects, spiritual aspects, political science, economic science, or economics. For the virtual lab sessions, the meaning of the word environment is restricted to physical aspects and the three states of matter. Gaseous, generally meaning air; liquid, generally meaning water; and solid, meaning terrestrial, that includes rocks and solids. The techniques for environmental quality and environmental pollution are covered with this sense in the virtual lab sessions that will follow. In other words, in the scope of the virtual lab sessions, we will only talk about the material or physical aspects of the environment, typically seen in three different states of the matter: air, water, and solids. Gaseous phase, liquid phase, and solid phase. That does not mean we do not have techniques or methods for non-material or the software or the non-physical part of the environment. Okay? There are parameters, techniques, methods that are used by social scientists, economists, political pundits to assess the effect of aggregate of conditions or influences. And these parameters, techniques, or methods are covered under social sciences or economics or political sciences. And when you study that part of the environment, okay, you will also look at those techniques. With this background, the techniques for monitoring environmental quality and environmental pollution, that is, again I will repeat, we will be covering the physical aspects of the environment or material aspects of the environment. The non-material aspects of the environment is entirely a different game, and they are covered under separate discipline. We can say that is humanities and social sciences, or sometimes computer science or economics, and so on and so forth. For this particular lab sessions, we will essentially be talking about the physical part of the environment, okay, and this means we will be learning techniques for assessing the quality of water or quality of air or solids and rocks that surrounds someone, meaning various life forms, or as you can see here, this is a water environment. This is also a water environment. While when you are looking at this we are looking at air environment. And when we look at with respect to someone or something, when we are talking about someone, we are talking about this life form or this life form or this life form. Okay. So for water, whatever life forms that exist in water, those life forms will be affected by water environment. For some life forms, part of their life they spend in air, partly they depend upon water, like this. Okay? So for them both air and water is important. Similarly, when we are talking about something includes various other things, like for example you see here, something means the things that we are talking about. It could be our property, that is equipment, appliances, our buildings, our furniture, crops, soil, rock, minerals, trees, etc. Even various water bodies for that matter, okay, which is a resource for us. That's also a thing for us. Or the atmosphere itself in which we all live, okay, and the physical aspects of the environment in general, like, so we can water, air, soil, and together is referred to as the physical environment. So in general, the environment itself gets affected by the conditions or the physical changes in the environment. Similarly, the techniques for pollution monitoring means techniques for assessing the excess or deficiency of various substances that are present in the three components of the physical environment in three different states of the matter: gaseous, liquid, and solid. For example, when you are looking at this liquid, in this liquid, which is water essentially, there can be other things present other than the water. What can be present in water other than water? Water being a liquid, you can have liquid mixed in liquid, you can have solids in liquid, or you can have gases in liquid. That is, say, dissolved oxygen. When oxygen is dissolved in water, or nitrogen is dissolved in water, or carbon dioxide is dissolved in water. So we have gases in liquid. Okay? So we are talking about physical environment in three different states of the matter: gaseous, liquid, and solid. And in these three phases, which is referred to as the dispersion phase, there can be other things, and the other component is referred to as the dispersant, and we will give examples of that. For example, it would be gases in gaseous environment when you are talking about air. Okay, so we can define composition of the clean air. If anything other than what we define as a clean air composition is present in air, for example, you can have carbon monoxide, which is present more than in concentration than what is there in the clean air. Or we can have hydrogen sulfide as a gas, we can have sulfur dioxide in air, we can have ammonia, or you can have volatile organics. For example, you have acetone, you have chloroform. Now these substances, when they vaporize, they become gaseous parts, and that their presence is in the air, so we call it as gases in gases. Okay? Or other example could be, you can have liquid in gaseous environment. Good example is when water droplets are suspended in air, and there are too many water droplets, it's thick concentration, then that is what we refer to as fog. Okay. Or we can have solids in gaseous environment. For example, when dust or soil is suspended in air, okay, that is the solid particulate matter in air. That is generally referred to as aerosols. Or we can have gases in liquid. Okay. For example, as I said, dissolved oxygen, or for that matter any other gas which is dissolved in liquid or in water. We can also have liquid in liquid. A very good example of liquid in liquid is oil dispersed in water. And there are several instances where we can see oil getting mixed in water. Or we can have solid in liquid. Okay? And solids in water either dissolved or suspended. Okay? Like for example, when we talk about salt in water. So salt is solid, but it is put in water, it dissolves. So it's a dissolved solids. Or you can have soil particulates, which is part of the liquid, that doesn't dissolve, so that we call it as suspended solids. Okay? So you can have solid in liquid either as dissolved solids or as suspended solids. Or we can have gases in solids. Okay? Or liquid in solid. For example, a good example of liquid in solid is the water present in the soil, which we know as moisture. So moisture in soil is liquid in solid medium and solid in solid. There are several examples of solid in solid. Like for example, if I look at say lime powder, and in that lime powder something else is mixed, say soil is mixed. So I consider that as impurity in the lime powder. It can be other way also. The lime powder is mixed in soil. Okay? Then in that case, lime is an impurity in solid. So when we say medium, medium means it is much in larger fraction compared to the dispersion. Okay? So in general, the dispersion medium could be gaseous, as in case of air, or liquid, as in case of water, and solid, as in case of rocks and soils. And impurities could be dispersant, that is impurities referred to as impurities. However, impurities, as I said earlier also, should not be confused with pollutants. Not all impurities can be called as or will qualify as pollutants. And the second part of the pollution monitoring is identifying and characterizing the sources, okay, various sources of pollution. And the sources again could be liquid sources, gaseous sources, or solid sources. As you see here, this is a liquid source. As you see here, here, or here, or here and here for that matter, these are all gaseous sources. Or what you see here is solid, right? So these are the sources of solid emissions. Okay. Further, the sources of pollution may be looked at as stationary or mobile or non-stationary. Like you see here, these sources, chimney here, is fixed, it doesn't move. So that's a stationary source of gaseous emissions. Or you see a pipe here, which is also fixed. So that's a stationary source of liquid pollution or liquid waste. Okay. Now when these sources are numerous and they are placed side by side, then it becomes a line source. For example, you have this, the number of pipes emitting or discharging very closely, or you have number of chimneys, okay, side by side. Then these can be considered as line source. Or when you have point sources, number of point sources dispersed or spread over an area, then it can as well be considered as area source. So sources of pollution could be stationary, and depending upon whether it is a point source or whether it is in line or it is spread over an area, we call it as area sources. Okay. So the stationary sources could be line sources, could be point sources, or could be area sources. And as I said, the chimney is a stationary, fixed or does not move, is a stationary source of gaseous pollution. Okay. A pipe is a stationary source of liquid pollution. Okay. And number of point sources in series or long sources are line sources. Okay. And number of point sources adjacent to each other are spread over an area. Okay. Point sources adjacent to each other are in an area, activity is spread over an area, that is area sources. Like you see here, fire over an oil spill in the ocean, or fire in the forest. Okay. Or sometimes you have a big solid waste dump and it catches fire, right? So these are all sources of emissions, but we call it as area sources because they are spread over an area. Sources of pollution could be mobile as well, like what you see here. This is a motorcycle which is moving, the pipe emission is moving, so we call it as emission sources. Similarly, any vehicular emission, be it auto rickshaw or be it car or be it a railway engine, these are all mobile sources of pollution, even including the ship. When it moves, now ship is very peculiar, it can also have both gaseous as well as liquid waste. So it can be a source of, mobile source of gaseous as well as liquid, and this is an area source of pollution. And sometimes this can also move, okay, when the entire oil spill floats and moves from one and there is fire, so that can also be considered as a mobile source of pollution, area source of pollution. When one considers pollution, particularly a physical environment or material environment or hardware, it is the presence of certain substances in a medium. And presence is useful or adds value, it can be said that the presence is desired or required, then the substance is referred to as a resource. For example, when oxygen is dissolved in water, it's essential. It's required for the aquatic organism to breathe. They take air, oxygen from the dissolved oxygen in water. So the presence of dissolved oxygen in water is a resource, is a useful thing. Okay? So if the presence of a substance, okay, adds value or is desired, then we call it as a resource. This is also true for any material. If that is present and you require it, it adds value to it, we like it and we value it and we call it as a resource. On the other hand, if the presence of a substance or even for that matter lack of it causes harmful or undesirable effects, then it is referred as pollutant. Like for example, you require certain amount of oxygen to be present in water from the consideration of fish. If the oxygen is present in low quantity, that is dissolved oxygen is less than what it should be, then the aquatic life is under stress. So we call that as a deficiency, and that we refer to as the state of pollution. Okay? Of course, the oxygen itself is not a pollutant, right? But the deficiency of the oxygen in water is considered as a state of pollution. The reason for depleting the oxygen may be different. Or when you have some substances present, for example, when hydrogen sulfide is dissolved in water, then it is unnecessary, it causes harm to certain things, and that's why it is referred to as a pollutant. So if the presence of a substance or lack of it causes harmful or undesired effect, then it is referred as pollutant. Saying it a different manner, if a substance is present at a place or time when they are necessary, okay, it is considered as a resource. If they are present at a place and time when they are unnecessary, then it is considered as a nuisance, or considered or referred or termed as pollutant. In other words, we can say that pollutants are nothing but resources, okay, but when they are out of time, out of place, then they become nuisance, and then they are referred to as pollutants. In other words, pollutants are nothing but resources out of place or time or both. Now talking about aquatic part of the physical environment, the interest is either in water quality assessment, like you see in these pictures. These are all clean water bodies where the aquatic life is very healthy. Okay, if we are assessing the water quality of these water bodies, then we call it as water quality assessment. Okay, so aquatic part of the physical environment, the interest is either in water quality assessment, or other interest could be like what you see in these two water bodies. Okay, what you see is there are too many other things which are causing problems for the aquatic body, and the presence of these substances, if we are trying to assess, then we refer to as pollution assessment. Okay, so for clean water bodies, one would like to assess the quality of water with respect to various life forms, or in some other context, some objects such as ships, pipes. For example, if you are using some material in water, for example, you are taking a pipeline through ocean or through a water body. In that case, if there is something which is present in the water which causes harm to the pipeline, then we are talking about causing harm to something, not someone. Okay, so when we are looking at pollution or water pollution or presence of pollutants in water, we look at it from both aspects, impact on someone or impact on something. Okay, so like for example, if I am using water in the boiler, now there my interest could be that the boiler material either should not get corroded or should not be forming scale. We will talk about it in future. So for polluted water bodies, the interest could be in assessing the levels of harmful or undesired desired substances, that is referred to as pollutants. The terms most commonly used for liquid waste is wastewater or effluents. So when we are talking about these discharges, we refer them as effluents or wastewater, be it here, be it here, be it here, or be it here. So in case of liquids, the discharges are typically referred as effluents or wastewater. But when we talk about ambient air, when we talk about air, the term that is most commonly used for monitoring surrounding air, like you see here, this person breathing the air, right? So that air is surrounding. So that is generally referred to as ambient air monitoring, whether of clean air or polluted air. Like for example, if you see here, here also you have air, there could be people here who would be breathing, but then in this air, because of the various activities that you see, vehicular pollution, some chimneys emitting something, or some liquid discharge coming in, and because of that there would be some things present in the air which is surrounding the various objects. Okay, it is for life form as well as for the materials. Like for example, if you look at this, here we are talking about the life forms. If you look at this picture, we are talking about water and air both. For this organism, when they are in air, they are breathing air. So air quality is important, and when they are in water, the water quality is important. Okay? And here when we are talking about, okay, it is not only life forms, but there are several other things, like I have these fans, or I have these buildings, okay, or this tower. So if the air quality is such, or the presence of things in the air is such that they are harmful to the material of the objects itself, like for example, I need to keep on painting this, okay, if the air is very corrosive and so on and so forth. Similarly, with respect to this tower, if there are harmful gases which can cause harm to the material, then that is also referred to as the presence of pollutant. And typically, when we release something in air, okay, unlike we call release of liquids as effluents, the release of gaseous things is typically referred as emission. Okay, so when we talk about air quality monitoring, we talk about ambient air monitoring, and when we talking about emitting something in the air in the gaseous form, we call that as emission. So with respect to air, we use the terminology ambient monitoring, and when with respect to sources, we use the term emission monitoring. Like for example, when I am trying to characterize various gaseous sources of pollution, like this, I don't call this as an effluent generally. The terminology that is used, that this is an emission. Similarly, what we see from the car is emission, or what you see here is also an emission, and we call this as fugitive emission. The reason being, it is spread over a certain area, and there could be several examples. For example, when you are talking about unloading a truck, okay, or firecrackers for that matter, which we use in many of our festivals or many other occasions. So that emission that comes out of those is referred to as fugitive emission. So if the activity is spread over an area, okay, like construction activity for that matter, and the dust and other emissions that are coming out of those are generally referred to as fugitive emission. So to be using very appropriate word, okay, I will repeat again. For liquids, we call it as wastewater or effluents, and for gaseous, we refer to as emissions. Okay. And for air, we call it as ambient air monitoring, and for water, we refer to as water quality assessment. And similarly, for solids, okay, on a similar note, in case of the terrestrial environment, assessment of the soil or rock is referred to as characterization of rocks, characterization of soils, etc. And monitoring of solid waste or sources of solid waste is done in terms of both quantity, either in terms of the volume that they occupy or in terms of the weight. And both are important, because if I have to transport it, I need to design the size of the truck, okay, and if I have to consider how much pressure they will exert on the tire, then I also need to know about the weight. So in case of solid waste, both volume as well as weight and that we call it as quantification of the solid waste. At the same time, it is also important to understand or know about the characteristics, and the characteristics are typically assessed in terms of, let's say, density of the solid waste, moisture content in the solid waste, or any other substances like carbon content, nitrogen content, sulfur content, and so on and so forth. So the solid wastes are typically characterized in terms of various parameters, and the quantification is done in terms of volume as well as weight on a certain time period. So summarizing about pollution sources, they could be stationary or non-stationary. As you see here. So pollution sources could be characterized as stationary or non-stationary, also referred as mobile for non-stationary, and that is mostly from vehicles. Liquid discharges are typically termed as effluents and gaseous as emissions. Pollution sources could also be classified as point and non-point. Okay. And the point and non-point sources could be over the surface or under the surface. If it is under the surface, then it is referred to as subsurface. If it is over the surface, then it is referred to as surface. So the sources of pollution can be classified as surface and subsurface, and depending upon whether they are in line or they are spread over an area or just emitting from a point, they could be called as point or non-point sources. Okay. Also, non-point sources could be referred as line sources or area sources. That includes fugitive emissions like from unloading of a truck or emission from construction activity. So environmental quality and environmental pollution is from various sources, and in order to understand both environmental quality and environmental pollution, we study them with different parameters, or we say that they have various dimensions. So environmental quality and environmental pollution aspects has many dimensions and may be broadly characterized as physical, chemical, physicochemical, or biological. Physical, chemical, physicochemical and biological dimensions may be assessed for three different phases of the environment. So I can talk about physicochemical parameters for solid, physicochemical parameters for liquid, physicochemical parameters for gaseous, that is air. So physical, chemical, physicochemical and biological dimensions may be assessed for three different phases of the environment: solid, liquid and gases. At the same time, solid phase of the environment is represented by rocks and solids, liquid phase is represented by water in general, and the gaseous phase by air. Monitoring or measurement or assessment may be done on the spot, also referred as on-site or in situ, like when you are inserting a probe and getting the measurement right there without taking out a portion of what is being emitted or discharged. That is referred to as on-site, on-the-spot measurement or in-situ measurement. Okay, like installing real-time sensors, and for that matter, like the observations that you get from satellite, right? So the things are in their place and we get the measurements done without disturbing the situation on the ground. So those kind of measurements are referred to as on the spot or on site or in situ measurement. But for many other things, we take out the sample, collect it in something, transport it, and then do the measurement in the laboratory. For such kind of thing, it is referred to as monitoring or measurements or assessment off-site, okay, by taking samples and analyzing it in the laboratory. So typically, the sampling or monitoring or measurement can be divided into on the spot, on site, or in situ, or the other class is off-site in the laboratory measurements. Samples could also be of solid phase, could also be liquid samples, or could be gaseous samples. So samples could be solid, that is soil samples, or rock samples, or solid waste samples for that matter, or liquid samples of water. They could be of water, they could be of wastewater, and that wastewater, as I said, we typically call it as effluents. Or you can have gaseous samples, okay, of ambient air or emissions coming out from the chimney or vehicles. It is important that the samples represent the whole or the entire population, because our results or whatever interpretation that we do, we assume that whatever is the characters of the sample is also the character of the whole or the entire population. So it is important that the samples represent the whole or entire population, and that is why it is important to have a sample that is representative. Here, sample collection requires appropriate procedure and system. So to be sample to be very representative, you must have a proper collection system or procedure. And the next step is always analysis of the samples, which is invariably done in the laboratory or off-site. And you will understand there is always a time gap between the collection of the sample and when it is analyzed in the laboratory. And so we must have a proper preservation technique. And preservation objective is that whatever the characteristics or the nature of the sample that you have at the time of collection should be same till you are analyzing. And in between sample collection and analysis, there is a transportation step that is involved, that you need to collect the sample and transport it to the laboratory. And in the laboratory also, as soon as it is delivered in the laboratory, it is not necessary that it will be analyzed immediately. There may be some time gap, and so you need to store that sample, preserve that sample in the laboratory as well. So you need appropriate preservation techniques during the transport as well as in the laboratory until the samples are analyzed. Okay? So the sample should be representative, there should be a proper collection procedure, there should be proper transportation and preservation procedure, okay, and then there should be a technique available for assessing the various parameters, which we call it as assessment, measurement in the laboratory. Okay. So sampling and analysis, we talk about either solid samples or liquid samples or gaseous samples. And for sampling and analysis of environmental sample, a typical environmental science and engineering laboratory will require facilities for preservation, conversion from one state to the other. Why conversion from one state to the other? For example, I may have an instrument which can only accept solid samples. But if my original sample is liquid sample, how do I analyze it in an instrument or using a technique which can only take solid sample? What I can always do is convert the liquid state into solid state. One of the simple technique is you lower the temperature, it freezes, it solidifies, it becomes a solid sample. Vice versa is also possible. I have a solid sample and my technique instrument can only take liquid sample. Then I have to convert the solid sample into liquid sample. Okay? In that case, either I dissolve it in water or I melt it. And by melting it, I can convert it into a liquid state. Okay? Similarly, it is possible to convert the gaseous sample into solid sample or the solid sample into gaseous sample. Okay? Like for example, if I want to measure the carbon content in a solid sample, and I can analyze the carbon dioxide in the gas. The analysis instrument that I have can detect carbon dioxide. Now how can I use this instrument to get the carbon content in the sample? What I can do is I can burn the carbon sample and convert carbon into carbon dioxide and measure the carbon dioxide in the gaseous phase. Okay? So it is always possible that you can convert the solid sample into liquid sample or gaseous sample, and gaseous sample into liquid or solid, and the liquid sample into solid at the gases. For example, if I want to have something in the liquid which is dissolved and I want to convert it into solid, I can always precipitate out. Okay? So that is converting from liquid phase to the solid phase. It is also possible that I can transfer it from one phase to the other phase. There is a difference between converting from one phase to the other phase and transferring from one phase to the other phase. I'll give you an example of what do I mean by transferring from one phase to the other. Like you take a piece of chalk and you have an ink bottle. You dip that chalk piece into ink. What will you see after some time? You will see that the chalk piece becomes blue or black depending upon what the color of the ink is. What exactly has happened? Whatever was there in the liquid has now come onto the chalk, which is a solid phase. And this is what we call it as transferring from one phase to the other phase. So while doing analysis, it is important that we must have these techniques available to us, either converting from one phase to the other or from transferring from one phase to the other. And then analyzing that particular phase, whether it is solid or liquid or gaseous. So a typical environmental engineering laboratory will have or will require facilities, first such as preservation, second that is conversion or transfer from one phase to the other, and the